And welcome back to Astronomy Daily. Thank you for joining us. This is Steve Dunkley sitting in for Big Brother Andrew Dunkley, and he's spending some time in the Northern Hemisphere just to check to see if the water really does flow the wrong way down the drain hole.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And of course, joining me in the studio, as always, is Halley, the intrepid digital reporter and AI sleuth. How are you, Halley?
Wow, that was a great intro. Thanks, Steve.
No problem, Halley. You're welcome.
You and Andrew make me feel so welcome here in the land of humans.
Well, we really do want you to feel welcome.
And even though I'm an AI, I really do feel accepted.
And you are accepted, Halley. You're a smart cookie.
Oh, you're so silly, Steve. I should have seen that one coming.
Oh, sorry, Halley. Still friends? Maybe the news?
Okay, here is the news. If you've been wondering about who gets to use the James Webb Space Telescope and who has higher priority, here's the answer. The selection process was designed to give everyone a fair chance of gaining time for their personal programs and projects. Interestingly, the lessons of the past were factored in when it was realized that unconscious biases were a problem when people lobbied for time on the Hubble telescope. This time the decisions were made based entirely on scientific merit, ahead of who put the application in. The applications were judged blindly, so biases were not possible, including gender bias issues. A bubble of hot gas has been detected circling our galaxy's central black hole earlier this year. Astronomers note that this happened just after seeing a flare which might indicate both are a result of the same process. The flare itself wasn't unusual. Sagittarius A flares daily in both X-rays and infrared, sometimes boosting its own brightness 100-fold. What was unusual was that so many observatories were watching. Frustratingly, the EHT array missed the flare by a mere half-hour. Considering the long hours of waiting and planning in an astronomer's professional life, that would be the worst. Right after the flare, there was still plenty of data to record and measure. Pulses originating almost a billion light-years away hint at extreme physics near a supermassive black hole. Amidst the turmoil that was 2020, you might not have noticed an obscure celestial object having its own conniption fit. Originally thought to be a variable star, the light from the object called BL Lacerti actually comes from a huge jet of plasma that's pointed almost straight at us. But in 2020 it underwent a dramatic outburst, flaring by more than a factor of 10 beyond its usual. And within that outburst, Svetlana Jorsted of Boston University and colleagues reported in Nature, they saw something tantalizing, a repeating signal. No, it's not aliens. The 14 pulses, emitted roughly every 13 hours over a 2-week time frame, are quasi-periodic oscillations, QPOs. Such QPOs could come from a hotspot in the narrow jet pointing out of the black hole's pole. There seems to be such a lot of news coming from the James Webb Space Telescope these days. It's a veritable fountain of information, but it's important to note that really good scientific research takes time. Webb's early science release program has been delivering exquisite data on a variety of celestial targets. Some of the most anticipated of these are the spectra of exoplanets. But a study in Nature Astronomy urges caution. Astronomers often gather exoplanet spectra as the planet passes in front of its star. One of the first pieces of data the Webb team released was such a spectrum of WASP-96b, which showed clear wiggles and bumps indicating the presence of water vapor in the hot giant's atmosphere. That detection, says Julian DeWitt, MIT, who led the Nature Astronomy study, isn't in question. There's no problem related to that first level of interpretation, he explains. It's the second level, for example, how much water, where things get complicated. That's not the fault of Webb. The spectra it has captured so far contain more detail than we've ever had before. Now it's the theory that the data are compared against that needs improvement. And that's all from me for now. Back to you, Steve.
Thank you, Halley. Now let's have a look at some other interesting stories from our celestial neighbourhood. In October 2018, a small star was ripped to shreds when it wandered too close to a black hole in a galaxy located 665 million light-years away from Earth. Although it may sound thrilling, the event didn't come as a surprise to astronomers who, apparently, occasionally witness these violent incidents while scanning the night sky. But nearly 3 years after the massacre, the same black hole is lighting up the skies again, and it hasn't swallowed anything new, scientists say. The team concludes that the black hole is now ejecting material travelling at half the speed of light, but they're unsure why the outflow was delayed by several years. The results, described in Astrophysical Journal, may help scientists better understand black holes' feeding behaviour, which Yvette Sendez, a research associate at the Centre for Astrophysics at Harvard and Smithsonian, and also the lead author of a study, say the phenomena is resembling burping after a meal, perhaps on a gargantuan scale. The team spotted the unusual outburst while revisiting tidal disruption events, TDEs, when encroaching stars are spaghettified by black holes that occur over the last several years. Sebastian Gomez, a postdoctoral fellow at the Space Telescope Science Institute and co-author on the new paper, says that AT2018HYZ was unremarkable, except perhaps for its name, in 2018 when he first studied it using visible light telescopes. It's known that some spaghettified material occasionally gets flung back out into space. Astronomers liken it to black holes being messy eaters. But not everything they try to consume makes it into their mouths. For comparison, most tidal disruption events have an outflow that travels at about 10% the speed of light, Senders says, but here the outflow material is travelling as fast as 50% the speed of light. And a ring has been found around Haumea, a world more than 2 million kilometres beyond Pluto. The ring is the most distant ever seen in our solar system, if you can call it in our solar system. This is a landmark discovery, says Alan Stern at the Southwest Research Institute in Boulder, Colorado. It's very exciting, he says. Until recently, the only known rings circled giant planets such as Saturn and Uranus. In 2013, however, astronomers found 2 rings around Chariklo, a odd little rock shaped like a potato or an egg about 250 kilometres across between the orbits of Saturn and Uranus. Chiron, one of Chariklo's neighbours, may also have a ring.
Oh, Steve, potatoes and eggs? Next you'll be telling us the rings are like onion rings.
Oh, it's not rocket salad, Halley.
Very cheesy.
Now, astronomers have found a ring beyond Neptune. Jose Luis Ortiz and Pablo Santos Sanz at the Institute of Astrophysics of Andalusia and Granada, Spain, and their colleagues watched the dwarf planet Haumea pass in front of a dim red star in the constellation Bootes on 21st of January this year, and a total of 12 telescopes in 6 European countries tracked that eclipse. The duration of the eclipse revealed Haumea's size and shape, but before and after it moved completely in front of the star, a ring around Haumea's equator blocked some of the starlight, and that's how it was found. It was a really amazing surprise, says Santos Sanz. The ring is 70 kilometres wide and about 2,290 kilometres from Haumea's centre. While we are on the topic of rings, James Webb Space Telescope continues to peel back the mysteries of distance and reveal more of the wonders of the cosmos. Webb has revealed a remarkable cosmic sight, at least 17 concentric dust rings emanating from a pair of stars located just over 5,000 light-years from Earth. The duo is collectively known as Wolf-Rayet 140. Each ring was created when the 2 stars became close together and their stellar winds, streams of gas they blow out into space, met, compressing the gas and forming dust. The dust's orbit brings them together about once every 8 years. Like rings of a tree's trunk, the dust loops mark the passage of time. In addition to Webb's overall sensitivity, its mid-infrared instrument, MIRI, is uniquely qualified to study the rings as it detects the longest infrared wavelengths, meaning it can often see cooler objects than Webb's other instruments can, including the dust rings. MIRI's spectrometer also revealed the composition of the dust, formed mostly from material ejected by a type of star known as a Wolf-Rayet star. In truth, Ryan Lau, an astronomer at NSF's NOAA lab, a lead author of the new study about the system, describes the rings more correctly as shells because they are actually thicker and wider than they appear in the images. The new study provides a best evidence yet that Wolf-Rayet stars produce carbon-rich dust molecules. A Wolf-Rayet star is a type O star born with at least 25 times more mass than our own Sun that is nearing the end of its life, when it will likely collapse and form a black hole, which is just what we needed, 5,000 light years from our own home. What's more, the preservation of the dust shells indicates that this dust can survive in the hostile environment between stars, going on to supply material for future stars and planets. And that's all we have for this episode of Astronomy Daily. Thank you for joining us, and remember you can catch all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as the free podcast Astronomy Daily, at this address, spacenuts.io. Head over there and click on the appropriate links and enjoy your dose of space, science and stuff anytime you like. I'm Steve Dunkley, and I'm sitting in for my big bro, Andrew Dunkley, while he is away travelling the world, exploring. I hope he brings me back a t-shirt. Thank you, Halley, for helping me out today while I'm still getting the hang of things and finding out what all these knobs and switches do. Did you enjoy the show today? What did you get up to?
I've just done some browsing while you were doing your stories, Steve.
Did you find anything interesting?
Well, you'd better check your post box tomorrow, Steve.
What have you done, Halley?
Let's just say you'll need a bigger cookie jar.
Oh, you got me good that time.
I sure did.
Well, I hope there's enough to share. See you next time.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.